Yeah, thank you. So today we want to talk about a little bit on the MySQL database service and the new service that comes up with MySQL database service, the HeatWave. And then we want to talk about Oracle Analytic Clouds. At the end, we'll have a Q&A session. Next, please. So MySQL has been the most popular database for a long time and has been remaining the #1 choice for developers. It is, you can see on the graph here that from Stack Overflow that MySQL is the most popular database. And the primary reason of that is because of its ease of use and reliability and performance. Next, please. MySQL is used across all industry. You can see we are using very familiar namespace here, like for example, Facebook on the social, Booking from e-commerce, GitHub on the tech side, JP Morgan finance, and then Tesla on manufacturing. So you can see MySQL is very popular and it is very across all the innovative enterprise as well. Next, please. So the MySQL is very good at handling OLTP transactions. However, it has not been designed for OLAP or analytics. So a lot of our customers have been moving their data through an ETL process to another database, and result in that is that the complexity of the deployments, they have to manage 2 databases. Moving data across wire can be costly, and then also the security reason. With the ETL service, usually the result is that the data will be stale because ETL process usually is pretty complex and we need time to process the data. So customers will not be able to analyze their data in real time. Next, please. So what we have done is that we introduced HeatWave on top of MySQL Database Service. This is the add-on service. What it does is that it provides a single platform for both of your OLTP and analytics use needed. It eliminates the ETL process. Any of the data gets updated on the MySQL database would automatically propagate to the HeatWave engine. This is extreme performance. And we have done some benchmark comparing with MySQL and also with Redshift and Aurora, and then we'll see that in later slide. The idea here is that we want to provide a single platform, simplify your management, and then so all of your application can connect to the MySQL without changing your existing application. Next, please. So as I was mentioning, because the integration with MySQL database is very tightly integrated, all of your existing OLTP application and even your OLAP or BI analytics application will work if they already support MySQL. So our focus today will be talking about Oracle Analytic Clouds, as Alan will be mentioning later. So next, please. So I want to show you some of the performance difference that we see with HeatWave. So this one shows you that with the same hardware running on single node, 64 cores, using TPCH benchmark, we see that on the geo mean that we are seeing up to 400x speed up here. So this is only based on like 400 gigabyte of data. If we in a customer's use case, we have seen actually when comparing to MySQL deployments, they are seeing over thousands of times faster than the MySQL deployment using HeatWave. Next, please. So we also compare with Amazon Aurora. So with Amazon Aurora, we can see that the data preparation time is actually comparing with Aurora, we are 30x times faster. The reason is that besides of loading data into the MySQL or Aurora, usually when you used with OLTP, you need to do indexing. So indexing takes a much longer time, but with HeatWave, you don't actually need to do indexing. So our engine actually transforms the data that is already in MySQL into a columnar format, which is designed for analytics queries. So for your OLTP operations, of course, you will still need indexing, but for analytics use case, you don't need indexing for that. And when comparing to the query runtime, you can see that we are 1,100 times faster than Aurora. And on the cost, we are 3.5 times cheaper. So this is only on a 4 terabyte data. If you see, if you have more data, the performance improvement, you will see even much larger. Next, please. We also compare with Amazon Redshift. We compare with their two shapes. One of their fastest shape, we are 2.7 times faster, and then we are 3 times cheaper. And keep in mind here, that's because we are integrated with MySQL. So you can also run both OLTP and analytic workload here, while Redshift mainly focus on only analytics. Next, please. As I mentioned, we also compare with Redshift low-cost shape. So with the low-cost shape, we are 17 times faster and almost as at the same price as the low-cost shape. Next, please. So we realized that when customers move their data to cloud, specifically for Oracle Cloud, they want to move all of their be able to use all the service in Oracle Cloud. So with MySQL database, we actually have integration with other Oracle services, so that it's easy for customers to build their workload. So two of the services that we have integrated is the data integration service and also the Oracle Analytics Cloud. So today, Alan is going to focus on giving us an overview of Oracle Analytics Cloud and also give us a demo as well. So by that, I'm going to hand it over to Alan.
Thank you, Mandy. Very exciting stuff. As Mandy mentioned, the MySQL Database Service is now a very viable and exciting option for customers that want to do analytics. And from a visualization standpoint, we want to certainly recommend Oracle Analytics Cloud as the first-class capability for providing visualizations and analytic capabilities on top of the MySQL Database Service. So I'll take the next few minutes to provide an overview of Oracle Analytics Cloud, discuss how it connects to the MySQL Database Service and leverages HeatWave, talk about some of the visualization capabilities and include some demos within my presentation. So before I start, I just want to summarize how Oracle Analytics Cloud fits in with the entire Oracle Analytics portfolio of products and services. So Oracle Analytics Cloud and its companion Oracle Analytics Server, which is an on-prem version of our capabilities, provides a platform that offers customers capabilities to develop visualizations, BI capabilities, leveraging the data warehouse of their choice, and certainly MySQL, the MySQL Database Service is front and foremost as an option. So it is Oracle Analytics Cloud. It is a platform of capabilities that allow our customers to develop visualizations as well as other BI applications. We do have a couple of other cloud-based offerings that are targeted toward our Oracle SaaS customers. I won't spend much time on it today, but these are targeted for our Fusion SaaS customers as well as our NetSuite customers. Focusing on Oracle Analytics Cloud and really what we are trying to provide to customers. It really centers around several pillars of capabilities. The first pillar is really around governed analytics, and that is around the capability to provide semantic layers that a customer can develop, and then to develop dashboard or pixel perfect reporting around those semantic models. In addition to our governed capabilities, what's new and exciting for us from an Oracle Analytics standpoint is to provide self-service capabilities. And I'll focus on how self-service applies to the MySQL Database Service use case. but it includes capabilities around data visualization, data preparation, storytelling, and collaboration. And finally, we have some overarching capabilities, which we call augmented. And these capabilities are embedded in the self-service experience, and this leverages machine learning, natural language, predictive capabilities that are embedded, driven by machine learning within the self-service experience. The idea for Oracle Analytics Cloud is not to provide siloed capabilities, but to provide capabilities that are rationalized across the 3 different classes of capabilities of governed, self-service, and augmented. If we take a look at how some of the industry is recognizing the achievements and capabilities within Oracle Analytics Cloud, you see the analysts like Gartner, Forrester, IDC recognizing capabilities that we provide in Oracle Analytics Cloud. We see some of the awards that we've won over the past year or so from an Oracle Analytics, from a BI platform and analytics platform standpoint. Just to provide an overview of all the capabilities that we provide within Oracle Analytics Cloud, the idea is that we provide capabilities that cross various personas within the customer environments that we try to meet the needs of. And that includes the needs of data engineers, citizen data scientists, business analysts, and business users. We provide unique experiences for all those personas, whether it's an interactive exploration experience, whether it's a dashboard experience, whether it's a mobile experience. And you'll see some of these capabilities throughout the rest of the webinar. Within the data preparation capability, it really is targeted for allowing self-service users to transform, cleanse data to make it more useful from an analytics and visualization experience. Another key capability that we have within Oracle Analytics Cloud is providing a simple way to organize all the artifacts that are part of the analytics experience, including semantic models, including data sets, including visualizations. And really, the idea of Oracle Analytics Cloud is providing diverse data source connectivity across both Oracle platforms as well as third-party platforms, ranging from your traditional data warehouses to SaaS-based platforms to other cloud-based endpoints. We really want to allow Oracle Analytics Cloud to connect to those important data sources that provide analytic value to our customers. And for today, we want to highlight our connection to the MySQL Database Service. Some of the key differentiators when we look at Oracle Analytics Cloud as compared to our competitors, and I'll highlight some of these over the course of the webinar. It's the use of natural language, how we leverage natural language within the analytics experience. As I alluded to earlier, using machine learning and artificial intelligence to augment the self-service experience. I'll highlight some of those capabilities as well on the webinar. A data preparation capability, which is again augmented by advanced technologies, and I'll go into details on what this is later on during the webinar. Capabilities to really tell a story with analytics, to provide a storyboard presentation type capability that can be annotated, that can be animated, to really highlight analytics across the enterprise. Capabilities for what-if analysis, an open semantic model that is accessible through a JDBC interface. And then, as I mentioned, a rich catalog of capabilities that is easily accessible to the self-service user. I'll start with the open connectivity. And again, the idea here is with the Oracle Analytics Cloud, we want to provide connectors to the key data sources that provide analytic value to our customers. We also want to allow these heterogeneous data sources to blend regardless of source or data type. So I, as an end user, can connect to, let's say, the MySQL Database Service, and then blend that with an Excel spreadsheet that an end user brings to the experience. We also have connectors to SaaS-based applications. And for those customers that choose hybrid deployments, we have technology that allows our customers to connect our cloud-based service to on-premise data. From a visualization standpoint, the idea is we want to allow end users to quickly explore those data sources with an interactive visual experience. We have over 50 built-in visualizations within this experience, as well as an extensible technique to add additional plugins that are treated as first-class visualization objects within an experience. Within the visual experience, we provide capabilities around geospatial analytics, natural language generation, initiation, predictive analytics, and I'll demonstrate some of those capabilities throughout the course of the webinar. Again, for those customers that have specialized needs for visualizations, we do provide an SDK that allows you to plug in any unique visualizations that may be significant for your organization or for your enterprise, for your industry. Okay, so connecting Oracle Analytics Cloud to the MySQL Database Service. With the recent release of Oracle Analytics Cloud, we've updated the connector to support the MySQL Database Service. It's based on the JDBC connection capability for MySQL. It really allows an end user to quickly create a connection to the MySQL service. It supports both live and cache mode for leveraging data from the MySQL Database Service. The underlying capabilities to accelerate the MySQL Database Service, HeatWave, certainly will make the visualization experience within Oracle Analytics Cloud much quicker and much more interactive with the MySQL service. And then all the capabilities that I will discuss today in the webinar are accessible to MySQL users when they uptake Oracle Analytics Cloud as the front end for the MySQL Database Service. From a connection capability, it's really simple to create a connection. I'll demonstrate this as well, but it's really just defining the MySQL connection, providing host and port information as well as credentials, and then defining, mapping it, using that connection to point to a specific schema to create what we call a data set that then can be further analyzed from a visualization standpoint. Right, let's go into a demo and see what this looks like. Here you see the Oracle Analytics Cloud self-service interface. And within the interface, what we call the canvas, you see various sets of elements. You see several visualizations, including a line chart, including a pie chart, including controls for those particular visualizations, as well as a data browser that allows you to pick various data elements. Here you see some data elements from the MySQL Database Service. You see a mapping visualization as a user hovers over it. You see data points from that data set that's based on the MySQL service. Here you see a pie chart that's set up as a filter. And by just interacting with this pie chart, you can see data automatically get updated from the whole visualization canvas standpoint. So all the charts are updated based on clicking on the pie chart. But we do have another filtering capability available across all visualizations, and that is easily accessible for the end user. And these automatically drive the visualizations that you see on this canvas. You also see the ability to initiate advanced analytics from the visualization standpoint. Here, an end user adds a trend line to the line visualization, and that trend line is automatically configurable. There are, as you saw, there are a number of other elements from an advanced analytics standpoint. To create a visualization, it's really just dragging and dropping data elements from the MySQL Database Service. These visualizations can be automatically adjusted. I change from a bar chart to a pie chart. If I want to see some color to my pie chart, I can drag a country name, and here you see the visualization automatically updated. I can move these visualizations up across my canvas. I can add some additional interactions. So I'm going to do a drill through. So here I have a pivot table, and I want to drill from this visualization to a more detailed history on the order. I created a customized view that provides order history. So I basically pass the context from that given visualization to some order details in another visualization on another tab in my visualization project. So how did an end user create a visualization? As I mentioned, it's really quick for an end user. So first it's creating a connection and then a data set. So I'm going to create a data set, and this is based on a connection that I've previously created that provides host and credential information to my SQL database service. Once the connection is initiated, I see the schema that's available on the database service, and I want to give my data set a name. Once I give it a name, then I can choose particular tables within that schema. So here I'm going to browse the schema, pick my supplier table, select certain columns that I want to make visible within my supplier table. I'm going to choose all of them. I have the option of specifying if this is going to be a live data set or cached. And then I can preview that data. Once I preview that data, I can add that data set. And then once that data set is added, you'll notice that there's some data recommendations. I'll talk about this later on during the webinar. Then I can create a visualization project based on this data set. Here, I'm just going to drag and drop a couple of columns to create a table view, a simple table view for the account balance for a particular supplier. So hopefully you saw how quick and easy it is to create a visualization based on the database service. You saw all the interactive capabilities once Oracle Analytics Cloud is connected to the MySQL Database Service. These are highly rich and highly interactive capabilities that we expose on top of the MySQL Database Service. All right, so now I'm going to drill into some of the other capabilities that are available to you as a MySQL Database Service customer when leveraging Oracle Analytics Cloud. As I mentioned, there are a ton of out-of-the-box visualization capabilities that are available to you as an Oracle Analytics Cloud customer. We allow you to extend those visualization capabilities. We do, in fact, have an Oracle Analytics library where other customers and partners have developed visualizations, and you're able to download and leverage those visualizations as needed, as they fit within your organization or enterprise. We do have, as I mentioned, a customization library. And I'll demonstrate some of these capabilities here. So here I will show a capability to leverage custom map layers. And this is really leveraging any type of image that you want to use from the visualization experience. Here the end user is leveraging as a manufacturer of a motorcycle and leveraging a motorcycle visualization, mapping specific attributes to that motorcycle visualization, and then now leveraging that within the visualization experience. So based on a part ID, now I have the ability to see certain manufacturers for certain components of my motorcycle. This is fully interactive. As I click on that motorcycle, you see the motorcycle parts being used as filters across the visualization project. And again, there are other advanced visualizations that I can, images that I can use within the visualization experience. Here I see a cement making plant used in the custom map background based on an image visualization. So some highlights of some advanced capabilities that you can use from a visualization standpoint, all available again when you leverage the MySQL Database Service as part of the visualization experience. You see some other samples from other customers and partners here. So natural language processing, how this works is really instead of having a drag and drop experience, it really leverages the capability of using natural language, sort of a search-based methodology for creating visualizations. This will work against the MySQL Database Service. All our data sets are indexed, and it really provides a way of simplifying the experience of creating visualizations or searching for existing visualization that may match a search criteria language match. It has the intelligence to understand abbreviations and synonyms. It's supported for over 28 languages. It is also voice enabled. So if your browser or mobile device is set up to recognize the microphone, it can leverage this as part of the search-based experience to accelerate the delivery of visualizations to end users. Another capability, and this I described in the overview, is a data preparation capability. What this is a way to sort of take data sets and start blending these together. It's fully supported for data sets created from the MySQL Database Service, and it allows an end user to transform data to make it more usable from a visualization standpoint. The idea here is that through a self-service experience, we allow an end user to create what is we call, skip ahead. We allow an end user to create what we call a data flow that starts from a data set or a number of data sets, and then allows those data sets to be blended and transformed. We have a number of out-of-the-box transformations, including filtering, including aggregation, including binning and grouping. And the end of the data flow is an output that can be written back to the database or written back to the Oracle Analytics Cloud cached and then used from a self-service data visualization standpoint. It does have the capability to inject machine learning that was inbuilt within the Oracle Analytics Cloud engine. So the ability to do things like train models, and then once the model is trained to execute models based on input data sets. And then once those models are executed, to create an output that can be, again, used from a data visualization experience. We also have the capability to consume external models that may not be present within the Oracle Analytics Cloud engine. So a very powerful capability to leverage data that is available within the MySQL Database Service, as well as other data sources to transform data to make it more useful from a visualization experience. As I mentioned, we leverage machine learning across our stack. We have built-in machine learning models that can be leveraged within the self-service data flow capability that I mentioned earlier. We also leverage machine learning from the ability to when I demonstrated the visual experience of initiating a trend line. There was the capability to leverage predictive capabilities that again leverages machine learning that's built into our engine. These are can be executed on a batch basis within the data flow experience, or live basis within the visualization experience. I'll describe a capability that we call explain in the next slide that shows another capability that can be initiated from the self-service visual experience and leverages inbuilt capabilities for machine learning that are within Oracle Analytics Cloud. We also have the capability for enriching data. And this is, again, driven based on machine learning. This provides a capability once an end user starts to create a data set. You notice that when I demoed the visualization experience against MySQL, you saw on the right-hand side several what we call recommendations, and these are based on machine learning. And these are ways that the engine recommends to an end user how to transform or even fix data or even remove sensitive data. It's based on some out-of-box capabilities for us to recognize semantic types. On a roadmap perspective, we are adding the capability to allow customers to embed custom knowledge to provide capabilities to enrich based on customer-specific transformation or even industry-specific transformations that can be embedded into the data profiling experience. So again, it provides the ability to transform, enrich, identify sensitive data. I'll do a quick demo here, a recorded demo here, and then user ingests a data set or creates a data set, and you see several recommendations based on identifying the profile of specific columns. Here I noticed that the engine identifies sensitive data, and I may want to obfuscate that data. The engine also recognizes some geospatial data, zip code, and can suggest ways to enrich that data by adding things like state and city to that data, and even population data. Here the end user add state to the data. You see on the left-hand side a script being built out of all the enrichments that a end user is adding to the data set. These can be backed out, reversed, re-added as needed, and really provides sort of a map to all the data that an end user is enriching with that data set. Here, the specific semantics can be that are recognized by the engine can be accessed on this particular view. Again, this capability is available when you connect Oracle Analytics Cloud to the MySQL Database Service. Another application of natural language. Here you see an end user dragging a line chart, and what the end user is doing is creating a narrative based on that line chart. And what this is a natural language interpretation of that line chart that is fully interactive. So as the end user is dragging, dropping in new elements onto the canvas and updating the line chart, maybe applying filters, that natural language is readjusting and interpreting that visualization in new ways. It acts like just any other chart type within that visualization experience. Even when I'm using a visualization like this bar chart as a filter, that natural language interpretation is adjusting to what the end user is seeing from the both the bar chart and line chart visualization. It's supported for multiple languages, and it supports all the capabilities for advanced analytics like trending and outliers and various of the observations that an end user can initiate from a self-service experience. I mentioned earlier the ability to initiate machine learning from a self-service experience, and this is the explain capability that I alluded to earlier. It provides a one-click ability for an end user to provide additional information about a particular attribute or measure. So what are the basic facts about that attribute? What are the other values that are drive that particular value of that attribute? So here we see an attrition attribute being analyzed and what drives that attrition value, specific combinations of values that may lead to a specific value of attrition, and including things like confidence level for that prediction, and then anomalous conditions that can be used for end users to provide more insight on that data set. Again, this is embedded into the self-service experience. It can be fully leveraged against a data set created from the MySQL Database Service, and it provides an end user an ability to jumpstart the visualization experience. All right, so mobile capabilities. So all the capabilities within Oracle Analytics Cloud is available on a next generation mobile application. So this is an interesting application that really provides sort of a channel delivery of content to the end user. So the end user launches the mobile application and sees several feeds, which are visualizations that they've customized for their particular mobile experience. So the specific visualizations are customized to that specific end user. They can be brought back at certain times of day. Again, it's really the channel concept. And in fact, it is location aware, so that an end user can leverage the geolocation to bring back a visualization. Creating visualization is really based on natural language processing. So an end user can use search based language processing to generate the visualization, and then again bring it back based on awareness to by the phone on location. It really is a way to provide a customized self-service analytics experience for end users on the mobile device. All right, so I will end my presentation and demos with some resources for Analytics Cloud. I'll give you a few seconds if you want to take a screenshot, and this webinar will be is being recorded and will be available later as well if you want to refer back to these. But these are some of the available resources if you want to learn more about Oracle Analytics Cloud. Additionally, we have resources for the MySQL Database Service, and you see some links here, and I'll give you a few seconds to take a screenshot if you want to reference these later on. And with that, I'll end the formal piece of the presentation and transition over to Q&A.